Hello, everyone. Welcome to Your Desk University. I'm so excited to see you here today, and we are going to be talking about building a Lambda function on AWS using Python, and why would we even do that as architects, engineers, and contractors? So stay tuned. We have a great speaker for you today. And that being said, don't forget to subscribe. Now, of course, I'm not just telling you that just because, but we have some really good shows with IFC.js. We're going to go into detail about REST that are coming up very shortly. And if you subscribe and hit the bell, you will be able to get notified and see those notifications as they're coming in. With that, I do want to say, as always, a huge thank you to the team helping put this together, specifically John Skippers, who is in the background every time with me. And with that, I will introduce our speaker. Real short intro today. This is Murat Melek. He is actually one of my coworkers at Walter P. Moore. I'm really grateful to have him online with us today. He's going to be sharing about why we build apps at Walter P. Moore. And he's going to be talking a little bit about why it matters as architects and engineers. He's a really, really knowledgeable person in the world of data science, in the world of app development, and he's a great engineer. And with that, Murat, thank you so much for being on the show today with us.
Thanks, Timon. It's always a pleasure working with you, and thanks for that great introduction.
And he
Let me
actually
start by
works in the DC office with me. Sorry, I interrupted you. But he works in the DC office with me, and it's always a pleasure having him there. And he's been on the show before. But one of the things I think today we're going to be learning is specifically about Lambda functions in AWS. And some of you are experts and you know about all this stuff. But for those who don't know how to build these, this is going to be really, really practical. So, yeah. Thanks, Murat.
Thanks, Timon. Hello, everyone. I hope this is as interactive as possible. So please feel free to ask questions during the talk. So we are going to be talking, the title is Python websites on AWS, but pretty much we are going to go over fully managed services and Lambda functions like Timon mentioned. But even before that, right, as Timon mentioned, why would we bother, right? Why would we think about deploying our functions, our methodologies to cloud services? First of all, if you ask me these questions, I will answer, hey, it's easy to deploy. Anyone who tries to, scale their app across the company knows how difficult it is to make people install stuff, right? So it's very easy to deploy. No one needs to install anything. There's extended library availability. So if you are using specific, for example, Python libraries, they don't need to have it. It's accessible from anywhere. On the right is a Beanstalk app, which is pretty much running on an iPhone. You can personalize the user interface and experience. In fact, Timon, has been working on this a lot. User experience and interface. And of course, version control, right? As you make modifications, as you improve your models, or even, for example, for machine learning models, if you are training them again based on new data and deploying new ones, it's much easier to version control using cloud applications.
And if you watched the episode a few weeks ago about pipelines, pipelines can be set up and get to deploy these automatically for you.
That's a great point. Timon. And in fact, on the AEC space, we see startups coming up, basically providing some of these services for you. There's Victor, there's Calc3, basically starting with you from a template and helping you along the way. What we are going to do today is basically step by step, as an introduction, right? If you have an app, if you have a Python function, we are going to be deploying it to Elastic Beanstalk and AWS Lambda. Just a little bit about myself. As Timon mentioned, I'm working with him at Walter P. Morse Washington, D.C. office since 2020. I mean, this wasn't my regular trajectory. In 2006 at UCLA, during PhD, I was breaking columns, non-ductile reinforced concrete columns. Then started working for Arup Los Angeles. Real dive into computational design was working with Frank Gehry on Guggenheim Abu Dhabi. Crazy surfaces. There I started using Grasshopper so that we can basically match the structural scheme with the surfaces. And after that, everyone knows Grasshopper. You have limitations, especially back then. How can we start automating calculations? We dived into MATLAB, basically design process and automated calculation phase. Going to 2016, we were working on this crazy project, very competitive fee, 10 million square feet, small team, crazy deadline. Okay, we said, okay, we need to use Grasshopper, but Grasshopper by itself wasn't sufficient, so we started using Python, and that's really when I started really diving into Python. In 2018, started dealing with machine learning, did a concept design report on tall building design using machine learning. I said, hey, I really don't know what I'm doing, so I took a 1-year break, did a master's on data science at UC Berkeley, and joined Walter P. Moore DC in 2020. Unfortunately, I can't show you what we are doing. Most of it is confidential since 2020, but we are working on some great stuff with Timon and others. So that's an intro for me. So we are going to be talking about Amazon Web Services, Elastic Beanstalk, Elastic Container Service, API Gateway. This is, for most of you, this is a first time dealing with Amazon Web Services. For example, in our company, we are generally using Microsoft Azure, so that we are synced with our IT team. But as a side, I'd like to work on AWS services as well. Today, we will be using we will be using Elastic Beanstalk here, Lambda services, API Gateway, and Elastic Container Service. If you were to look at last year's Stack Overflow, developer survey results, AWS is give or take 50% of respondents use AWS, Azure, and Google Cloud follow it. So it's fairly popular platform. Let's talk about Elastic Beanstalk versus Lambda. Elastic Beanstalk is a platform as a service. It's fully managed. It's auto-scaled. It's always on. So once you deploy it, you really don't need to do much about it unless there's a major problem. And you are able to host and run applications with a front end when you are using Elastic Beanstalk. Lambda is a function as a service. It is serverless. It's auto-scaled. Runs when needed. This is a positive because your costs are much lower, right? If no one is using it, there is no cost. But on the flip side, there's something called cold start, right? When this function is initiated, it needs to basically warm up, run, and then respond back to you. So sometimes when you are running it after a long while, if it's idle for a long time, it takes a couple minutes to get a response back. So you need to play with your timeout results. And this is mainly designed to run backend as an event-driven function. All right. So this is a breakdown of my AWS cost. There is the other portion, which is tiny, around 1%. As you can see, Elastic Load Balancer and EC2 instances are the main ones, main cost items. And these are mostly associated with Elastic Beanstalk. Elastic Container Services, some cost as well, but it is small compared to what Elastic Load Balancer is, consuming.
And are you going to go into detail about what each of these kind of three compartments are?
Thank
Minus the government department. I think we all understand the tax at the top, but yeah.
Tax, yes, tax is tax. But Elastic Load Balancer is once you deploy your app, right? Depending on how many people are going to use it, maybe you deploy an app, one person is going to use it. It doesn't need to scale, right? But if this app is going to be used by hundreds and hundreds of people, it needs to scale, right? So it needs a load balancer and scalability. So this basically takes care of that portion. Elastic Container Service is where your Docker images are. We'll go over this one. And EC2 instances are your compute instances. So basically your virtual, cloud instances, virtual computers, right, on the cloud. So there are other services, for example, Lambda service is less than 1%, so it's not here. Tiny cost. So Lambda, if we are talking about Lambda, as I mentioned, it is mostly a backend service. You can use other ways like API calls to interact with this backend service. We will go over this, but a good way is, for example, in this example, we are using Swiftlet in Rhino Grasshopper to get results from the service. On the other hand, Elastic Beanstalk is, as I mentioned, it's a fully managed service. You can deploy it with a front end, and back end is in the same package. In this example, what you are seeing is our internal Bay designer designing base using Elastic Beanstalk. If you were to look at the popular web frameworks, going back to Stack Overflow survey, here, if you were to zoom in, Django, Flask, and Fast API, these are popular web frameworks to do deploy Python applications. I know Timon likes to use Django. It's a little bit more comprehensive. It's a little bit more powerful, but a little bit harder to learn. Timon, correct me if that is a statement. But Flask is a little bit lightweight, easy to deploy, and Fast API is recently gaining popularity, especially for machine learning applications. Timon, would you like to add anything on Django, Flask, Fast API?
No, I think I was just looking at the percentages here and trying to understand what the data is showing here. Because obviously it's more than 100%, so there must be overlap being shown here, which makes sense. I think the one interesting thing is Flask, Django are never used together, so that means somewhere around 30% of web frameworks are built off of Python, which is a little bit. I was surprised by that.
Yeah, same here, and it's it's understandably React is so high up here at 42%. All right, let's go to the next one. So let's go to Elastic Beanstalk. So we are going to go over a very simple example, and if you are interested, if you are going too fast, in fact, on Medium there's an article going over this, and the repository is available on GitHub as well, in the same Medium articles. But very simply, we have a column, steel column, we are applying an axial load, and we are going to be using Flask to come up with a very simple calculator that calculates the axial load capacity of the column. Inputs are moment of inertia, section area, embrace length, modulus of elasticity, and yield stress. Right? We need to consider flexural buckling, torsional buckling, local flange buckling, of course, and our relationship, our critical capacity to yield strength is nonlinear, and depending on where you are in terms of slenderness ratio, you have different equations, right? So if I was to go to my VS Code, the Elastic Beanstalk application for this one compromises of an application.py. We are going to go over this thing. We have another Python function which basically calculates the XC load capacity, a very small short function. There is a folder called templates. In this folder is our index.html. Again, this is very, very simple. And at the end of this talk, we will be sharing the GitHub repository. So if you want to go in and have a look at it, you can. But pretty much, it's looking for inputs, right? Moment of inertia, section area, effective length, yield stress, and so forth. And if there's a problem, and if there's a result, it will flash the result in blue color, all right?
So this is not just the API, is that right, Murat? Like this is a building in a very simple format, just a form that you can use it for your inputs.
Exactly. This is a full application going to be running on Elastic Beanstalk. And to be honest, with with ChatGPT's advent, you can even say, okay, ChatGPT, I have these inputs, give me an HTML file with Bootstrap, right? You'll get it.
Yeah, so, and I think coming back to your comment about Django versus Flask, this is really light, right? React is somewhere, at the lowest end of like 15 files and a whole folder of modules. This is, 5 files with 30 to 50 lines in each file. It's much, and Django is also in the more like 20 files direction side of things.
Yeah, I think it's fair to say that this is okay for simple applications, but as you are, you wouldn't build a platform out of Flask, Okay, let's go to application.py. This is the main file Elastic Beanstalk is going to be looking at. First we are importing Flask, right? Oops. Render template, request redirect flash. We're going to go over this very quickly. It's importing our custom function, which is column capacity simple. It's basically giving you back the column capacity based on your inputs, right? First, we are initializing the Flask application, generating a random secret key. And I may be wrong, but Elastic Beanstalk, if I remember, for some reason doesn't work without this, but I may be wrong. It has been a while. And first of all, we define the route for the home page. So when someone calls for the web page for the app, it's going to be basically rendering our template, which is the index.html, right? And if someone posts something by clicking the button, we will get the moment of inertia, section area, effective length of the column, and other inputs. The code will check whether all the inputs are in there. If all inputs are given, right? If the user has input all the inputs, it will basically calculate PN, basically XC load capacity calculation, and then it will say, hey, the output is the design XC capacity of the column is this value, right? And you remember we were up here, we were importing Flash, and in the index.html, we were, hey, for message in get flashed messages, right? This is basically flashing that message for you. this is no way, you do a regular app, but this is as simple as it gets, all right? It will flash the output. If, the user for some reason forgot to input one of the inputs, it will basically going to say, hey, please fill all of the boxes, all right? And this is going to be basically running the function for us. I don't want to go into too much detail for the, how we calculate the XE load capacity of a column. I know probably we have, viewers from all fields, but basically we will be providing this function to you as well. Now,
and that's like any function that someone wants to put in, right? I think that's why you're kind of like
yes.
jumping over that, because that's
exactly.
not the point.
To be honest, you don't even need this. I like it to keep them separate, but you can pretty much copy this part and paste it into your application.py. Even that will be fine. But I like keeping them separate, right? So you can even use this for other purposes as well, and cleaner code. There are a few more things. There's this my first environment folder. We are going to be talking about this one. There's a zip file and there's the requirements.txt. Requirements.txt is basically telling Elastic Beanstalk, hey, in order to run this, I need these libraries. These are my dependencies, right? So let's talk about how we are going to get to this requirements.txt. So we talked about, hey, we are application.py, column capacity simple, code is available here again, but we need the requirements.txt. So why do we, and how do we do this, right? All of us have our own computers, either Mac, either a PC, and gazillions of Python libraries are installed in it, right? I did this check, I think a couple months ago. I had over 250 Python modules from Bouquet to NumPy. So if your code is running on your computer, it doesn't mean that it's going to run on another environment, right? So we need to basically create a bubble so we can really make sure that our application is running. So we first initiate a virtual environment. This is how we do it, venv, and this is our virtual environment. This is how we activate it. And once you activate it, you are basically within this bubble now. If I was to run the application in this bubble, it wouldn't run. It will say, hey, I don't know what Flask is. Okay. So in this environment, we pip install Flask, right? You remember the folder, my first environment folder here, in here. This is basically generated by that virtual environment. It's basically generated. Then once, for this simple example, the only dependency is Flask, I can say, hey, I want to freeze this, whatever I installed, I want to freeze it to requirements.txt, and then voila, we have the requirements.txt file. I can now deactivate my environment. Now I'm back to normal. So based on this one, we know that for the Elastic Beanstalk app, I need to be sending the templates, application.py, column capacity simple.py, and requirements.txt. So I'll be basically selecting these four and zipping them into column capacity simple.zip. All right. So we prepared our Flask files. There we go. Column capacity simple.zip. We go into the Elastic Beanstalk, press the create environment button. All right, this is an Elastic Beanstalk app already running in there. It will ask the question, hey, what kind of an environment do you want? We are saying, hey, we want a web server environment. I'm going to be calling it column capacity simple. All right. Choose an application name. And then we pick Python and platform versions. I want a managed platform. It's a Python platform. 3.11. I generally use whatever platform it's recommending to use. And here you have basically the option to use an existing version or a sample application or upload your code. Basically, I'm just going to be uploading a zip file, a local file. I call this version Your Desk University 01. Then we upload our file. And here we go. Here's our application. This is basically, I deployed this half an hour before we met. A very simple UI. I can basically say I have 500 inch over 4, let's say 10. Embrace length is 12 feet. Just about 20,000 PSI. And let's say I forgot to enter this one. It will say, hey, please fill all the boxes. Now I need to put into this one. Let's say 20. It's very fast, 862 kips, right? It's a very simple application. Timon, if there are any questions,
this is great. I think it's really simply put together, and helpful. And I think like thinking about the applications that are very similar to this, whether it's for space design, or whether it's room load, or whether it's a mechanical or an architectural or structural calculation, it can kind of be anything. And I think this is a good kind of like example you're showing us.
For time's sake, let's move on to Lambda, because Lambda is very, very powerful, especially if you are deploying machine learning applications. These pickled applications. It's very nimble. It's very low cost. It's very easy to deploy. So let's jump into Lambda. All right. It's for our simple column designer. If I was deploying the same thing, the only thing I need is a Lambda function with no layers. I'm going to describe what a layer is. You need an API gateway, so when the request and response are being transmitted to the user, it's basically acting as the gateway. All right. So we say, oh, okay, I'm going to start from scratch. Simple column capacity. Runtime Python 3.9. We are going to be talking about this container image in a bit, about Docker, but for the simple app, you can do from scratch. It has a very simple user interface. You can even work with your code in there in AWS Lambda. The only thing we are importing is JSON and math. Since this is not a Flask app anymore, right? It's a backend. The only thing we are importing JSON and math. So it's very light, no dependencies. You don't need to pip install anything, right? Everything Python can handle. First one is the function that's calculating the capacity. The second part is the Lambda handler part. I'm going to go into this a little more in detail in a bit, which is basically the Lambda function. And the same thing, just we did a minute ago, using Elastic Beanstalk with a UI. Right now I'm in Grasshopper. I'm using Swiftlet plugin. Same inputs, similar inputs, and then it's basically giving me capacities. All right, this application is a little bit, as you can see, is giving me a little bit more information. It's giving me the section size based on the XE load demand I'm giving it. It's even giving me a DCR, and the weight per foot. So this is a little bit more, complicated than our simple application. So let's see how we deal with this one, right? So this one is doing a little bit more compared to the simple application we did a minute ago. That's why we will be using a layer this time. Okay, and the layer is very, very handy. So let's say our original function, right? A simple function, but this time we need to import pandas so that our model can run, right? I don't want to, I can't pip install anything, right, in here, right, with Lambda. So the approach they are taking is, hey, you can add a layer to it. And as you can see, I'm importing pandas this time. It's using a database for the ASC section sizes. It's basically reading the ASC shapes database file and using pandas to find the optimum column size, right, from that data frame. So if we want to add a layer, there are two ways we can go about it. One way is if you have multiple dependencies you need to be installing, you need to generate your custom layer. I'm not going to go into too much detail about that one, mainly because it's a pain in the neck. You are constrained by the limit of your zip files. I believe it's 50 megabytes. For example, if you are trying to generate a layer with pandas, numpy, scikit-learn, scipy, whatever, it's very easy to go beyond 50 megabytes. So it's a hassle. But if you are dealing with one or two dependencies, even AWS has its own pre-built layers which you can import directly. You don't need to prepare it. It basically has the main things you need for data wrangling, including pandas.
And do those AWS layers have the same size limitations of 50 megabytes to them as well?
Yes. Yeah, but they basically refined it so that it abides by that rule, but it has been curated by AWS, so it is as efficient as it gets. So if you are just using pandas, I would recommend, hey, just use the previous layer.
That makes sense.
I'm not going into too much layers because at least my personal experience, I think it's more cumbersome to basically building your own layers, etc. I had done that in the past. I don't recommend it. We will be talking about Docker just in a second. But in order to make this Lambda layer work, right, we need an API gateway. I know I'm a little bit breezing through some of this. Stop me anytime. But also the Medium articles include more detail as well. But if you wanted to generate this API gateway, right? I'm just going to go into here. All right. So this is Amazon API gateway. If I was wanting to create a new API, it will ask me, hey, what kind of an API you want? We are using REST and HTTP APIs generally. I believe we are working with the REST API here. Let me go back here. Let's go to the column Excel capacity. It's a REST API. Okay. And then in here, as you can see, it is connected to the still column Excel capacity Lambda function on this end. At this end, it is basically there's a test environment where we can test. We can, when we are doing the integration request, this is where we call the Lambda function. So if I wanted to change this guy, I can. So as you can see, there are multiple Lambda functions which I can use here. I'm going to cancel. If I was to go back, if I go to the method request, I define query string parameters which are required. The user will get an error message if any of these query string parameters are missing. And then I can also test this guy, basically to make sure that it's working. Basically, I can send a test input, query string here. It will run the test. as I mentioned, cold start, right? The first run will be a little bit slower than the rest. But if you
And that's
want to
because
keep it,
everything's kind of booting up, loading into the
yeah,
data frame
exactly.
or
So
into
as
the
you can
Amazon
see,
server.
right now you got the result. But if I was to change any of these results, let's say 800 kips, and test it again, it is much faster, right away. So right now it's on. After a while, it will go idle. You can set the time. So this is Lambda function. Again, if you are more interested, want to go step by step, Medium article goes over it step by step. Here we tested it. If you wanted to test it on your browser, you can basically enter your URL address and your query string parameters, right? Everything concatenated with a AND symbol. You will get the result. But also you can use Sergey Pikach's Simflet plugin. I will strongly recommend. It's a great plugin for Grasshopper. It will give you your results back as well. Now, I think, Timon, we have a little bit more time, so let's look into a more complex application.
Yeah.
Now, as you can see, I said it's plus plus. It is getting embodied carbon values now. We will be basically using AWS API Gateway, AWS Lambda, AWS Elastic Container Registry, Docker, and building transparencies EC3 tool. Of course, I'm not using Python functions written by myself, but the Python wrapper developed by Jared Friedman, and I guess a shameless plugin for him for coming up in a couple of weeks, right, Timon?
Yep. 2 weeks away.
So, all right. So in this one, we have another Lambda function. When I went to this Lambda function, it says, hey, no code preview is available. All right. Because it is using a Docker image. There is no function to be seen anywhere, right? API gateway is the same, and we are not using any layers. So this is my preferred way if you are using a more complex deployment. For example, this is the Lambda function for this deployment. This is the Lambda function. Let's go over it in a bit. We have a Lambda handler, which is pretty much looking for the query string parameters, ultimate XE load, column floor to floor, still yield stress, right? It will try to see whether all the inputs are in there. If basically there is one of them is missing, it will return back an error message, right? We are using a shape database file. This is AAC database. And then basically we are calling for the column capacity. Hey, give me a column size based on these floor-to-floor and XU loads. Okay. We will get a column design out, and then we will get the weight out of this column design, and then push it to another function this time, right? Another function that is calculating the embodied carbon values. And then at the end, once the embodied carbon values are calculated, it is returning an object as header, and we are not using a header, but just a body, and we are using a JSON format response back. But let's look at this GWB value function very quickly. Calculate embedded carbon, and this is basically the only reason I want to go in here. I'm sure Jared is going to go into more detail, but as you can see, we are importing a library that's probably not in AWS curated layers, right? So you need to pip install it, right? So, and we are also importing pandas. So for sure, I should not show the token, but basically we are importing it right in. All right. So in here also we have the Docker file. The Docker file is pretty simple. In the Medium article, it's provided for you. It is using AWS Lambda Python 3.9 image. It pip installs pandas and Jared's EC3 Python wrapper. And then it copies column capacity, Lambda function, calculate embodied carbon and shape database files there, and then runs the Lambda function. This is it. It's very simple Docker container. So what we are building is an image, Docker image. Docker, if you were to go back to our presentation file, is if you were to look at all other tools out there, you know, aside from web frameworks, computing languages, if you ask the users of Stack Overflow, including professional developers and people learning to code, NPM, of course, but Docker with 63% used everywhere. Right? Kubernetes is used to manage multiple Docker containers. I don't use it, but Docker, as you can see, is very popular. So this is basically creating an image of a container, right? So you can think container like in a bubble, again, a small bubble running whatever you want it to run, basically a very slim version of Python 3.9, curated for Lambda by AWS, pip installed dependencies told by you, and just you can think of as a computer just for your Lambda function, right? But the image is not running it, right? Image is a blueprint of the containers, Docker containers that are going to run that code. And you can create as many images, as many containers from that image, run them concurrently. But first, we need to build this image and, you know, deploy it to some place.
So I'm curious. Right? You build all these apps on your computer. How many virtual environments do you have locally?
Good point. I should be more organized, but I like to, you know, generate virtual environments based on the project I'm working on, and then get rid of it once I'm not using it anymore.
I was going to say, because in JavaScript, I have the same problem, and I end up, you know, I can imagine pandas, you end up having it installed 20 times on your computer inside of every virtual environment.
Exactly. And I'm not sure whether right now Docker is running, but same with Docker images as well. They can get out of hand very quickly, you know, then you realize, hey, I don't have any space in my computer anymore. So again, you can go to the Medium article if you want to go step by step, but we will be basically building Docker images and deploying them to the container registry. Okay. Right. Let's go. All right. So the first thing we do is go to Amazon Elastic Container Registry. We create a repository for ourselves. This is where we hold the images, you know, for that particular project. This one is a private one, and then the name of the repository is column EC calculate, right? Once I generate that repository, AWS provides you all the steps to build and push the Docker to this repository. It's pretty straightforward, but you need to have Docker and AWS command line interface installed. All right, very straightforward. Once that is deployed to AWS ECR when I'm generating my Lambda function. You remember last time we were authoring from scratch with, when we were doing the simple AWS Lambda function. This time we pick container image, and we basically provide the function name and the image location. And you don't need to know this address. Pretty much when you press this browse image, you can browse from your Amazon ECR. And this is the great thing. Doing versions is fairly straightforward. You are basically same function. You can basically change just the container image if you want to. So again, you can call it from your browser, or you can pretty much use a Swiftlet application. This works fine. I don't know how we are doing on time. Of course,
Yeah,
good.
no, I think this is great.
And if you want any of these steps by steps, all of them are the Medium article. Some of the GitHub's repositories are all there as well. I hope you enjoyed slides. And if there are any questions, happy to answer.
Yeah, thanks. I'm looking, I don't see any questions right now. If there are any, please post them. I think I've been fielding some as we've been going. Thank you, Murat, for putting that together, for kind of showcasing what I saw was kind of multiple examples of how to build these on AWS. You had mentioned that we do Azure here at Walter P. Moore. I've also found that Firebase is really easy to deploy to. So sometimes when I'm testing something in JavaScript, I can just say Firebase deploy and it sends a new version up, and it's so easy that I just kind of fall back on that. But yeah, thank you so much. Do you have any hints? Any other things or any things you think about when you're building these Docker images? It kind of applies kind of across apps. I know they can be very specific, but you might have some hints from having done them over and over.
No, Timon, great point. Two things. Try to be nimble as possible. Don't use dependencies you don't need. But like to your point, if you are doing this machine learning apps or data science apps or others, which constantly use the same thing, NumPy, scikit-learn, pandas, you can use the same Docker file with some minor modifications over and over again, right? To generally, especially for Lambda, it's copy-paste for me, right? Copy-paste, change a couple lines of code where I'm changing just my functions, Python functions, and then you are done.
Yeah. And then on the layers that you were talking about, is that something that you can layer on top of each other? So you could have a base layer and then another layer.
Yeah, but it's at least my experience has been, Timon, I was able to make some of them work, but some of them, like trying to find the error is so difficult. It can't. Oh, I can't read this. I can't read that. It's very specific how you zip that layer. How do you custom build that layer? So it's not my preference.
Not your preferred. Your preferred is either the really simple kind of custom way, or the advanced way. And I appreciate it. I didn't know about the kind of the Python editor that exists that you can just kind of do directly inside of AWS as you're working. Seems like a pretty handy way of.
It comes very handy for, especially if you have a pickle file, an ML pickle file, very, very handy. Right?
Because you could put the pickle ML file right up there. And that's small. Thank you. Let's see. I had one more other question. Looking here if there's any other questions. Thanks everyone for tuning in. This has been good. I'm trying to remember what my last question. Oh, you were talking about. I know that Docker images are often based off of kind of a base Docker. Have you experimented at all with redefining a base Docker so you're building off of something that you've used before? You talked about like using an old Docker file, but I think that what's that called? Is it the seed? I don't actually know the term for the thing.
The first thing, right? I mean, there are different versions, especially if you if you were to go to Stack Overflow, you will
Hmm.
find custom Docker files, which has that base image coming specifically built for that specific purpose. So you don't necessarily pip install dependencies on top of that one. You might want a Linux one, you might want something different with different dependencies, but there are custom ones out there if you Google it.
Yeah. Well, thank you. And thank you. You said you were kind of moving fast, but I find that that kind of thing is actually exactly what works really well. We all appreciate. So thank you for that. Thanks for all the prep you put into this. And I guess I'll see you tomorrow at work.
Yeah, pleasure.
All right. Thank you so
Bye.
much. And with that, thank you for tuning in. Thanks for taking time out of your day to join us. And I will be in Discord. You can go to our website, yourdeskuniversity.com, and find out a list of all the other episodes that are going to be available to you. And if you are watching this point in the show, you're committed, and I appreciate that. So give us a like, help us out, share this, share something you found helpful. It could really help the channel out, and we appreciate you and all that you do for us as well.